Here are your solutions to the review assignment number 15. So you're given two equations. This is the first one, e to the x, and the second one, ln x. And you're asked to find the area between 1/2 and 1. You may use a calculator if you want. So we can graph these and get a better look in terms of what we're doing here. So here's the graph of e to the x, and here's the graph of ln x. And we're going to go from 1/2 to 1. So if I sketch that, here's e to the x. Here is ln x. And picture 1/2 here to 1 here. This is the area that we're finding in between 1/2 and 1. So in calculus, finding the area is an integration question. So we're going to integrate from 1/2 to 1, and it's top subtract bottom. So that's e to the x minus ln x. All right, press pause, type that in the calculator. Let's see if you get the same answer as I get. So I got 1.223. There's A. It's done. In part B, it says now find the volume generated by revolving about the line y equals 4, which is like somewhere up here. So in order to do that, there's a space. We're revolving, so it's going to require 2 radii, a big radius and a small radius. So we have our setup. Pi, the bounds are the same. And then I just have to go from the line of revolution. So top subtract to the very bottom. So that's going to be 4 subtract ln x. That's the longest radius. And then top subtract bottom, the smaller radius, is going to be 4 subtract e to the x. And then type that in. Go ahead, press pause, and you get 23.609. In part C, it says you're given a function, h at x, that equals f at x, which is e to the x minus g at x, which is ln x. And you're asked to find the absolute minimum. So the absolute minimum is a table of values question. And we're always going to have the ends of it from 1/2 to 1. So I want you to plug 1/2 and use your calculator, e to the 1/2, subtract ln 1/2, and then write the answer down. I'm going to do the same thing. So at 1/2, you should get 2.342. Do the same thing for 1. E to the 1, subtract ln 1. Ln 1 is 0, so it's just e to the 1, which is 2.718. Is that what it is? I'm all in on E Day next year, February 7th. We'll see if anyone cares. And then the derivative equal to 0. So I want you to type this in. I want you to go, here, we'll do it. I want you to go menu algebra. Let's go back to this screen. Menu algebra solve. And then type in e to the x, subtract ln x, equals 0, comma x. And then, oh, wait a second. What did I do first? I got to take the derivative. So let's try it again. So the derivative of e to the x is e to the x, and the derivative of ln x is 1 over x. Let's do this again. All right, let's type it in right now. So let's go menu algebra and solve, and now we're going to go e to the x, subtract 1 over x, equals 0, comma x. And then see now what answer I get, and I get 0.567. That's what I need to know. That's considered a critical number. 0 would also be a critical number, but it's between 1/2 and 1. So that number is between 1/2 and 1. So plug that number in here, e to the 0.567, ln 0.567, subtract them. And then the answer is 2.330. And then the question is, what's the absolute maximum in that? So the absolute maximum is right here. That's the biggest number. And the absolute minimum is right here. So that's what I was looking for. What is the absolute max? What's the absolute min? And I answered it. All right, number 2. You're given the rate. I'm not going to write it down. I'm just going to call it E at t, but you see it there in your book. And that's the amount of people entering and it's rate, so it's already a derivative. And then the other one is L at t. That's the amount of people leaving. It's also a rate. This is a common question, right? Whether it's bees or people or cars or whatever you want. How are we going to answer this? Part A, and that's they're valid from 9 to 23, the hours during which the park is open. So it's measured in hours after midnight, so 9 a.m. To 11 p.m. ultimately. So how many people have entered the park by 5 p.m.? So entered the park means we're going to use E. So we're going to integrate, we're going to use the E for that. How many have entered by 5 p.m.? So it started at 9 and it ended at 17. And then type that in with the equation given in the question. And you get the answer. Rounded to 6,004 people. Part B, the price of admission to the park is $15 till 5 p.m. After 5, it goes down to 11. How many dollars are collected from admissions to the park on the given day? So we're going to go 15 times what we just did. That's how much it costs. Plus, now it's $11. Now, how many people are going to be there times that? That's 17 to, it closes, which is what, 23? And then type this in your calculator for how much money that would be. And that would be $104,048. Part C, let h at t equal, and you can see what it equals in your book, the value of h at 17, to the nearest whole number is that. Find the value of the derivative at 17. So the derivative of h means it's a substitution question. So it'll just be e at t minus l at t. So the derivative integration cross out, you plug t in for x. So there that is. That's the derivative. Then it's to plug in 17. So e at 17 minus l at 17. So then you just plug into the equation that's given, the integration question. Plug 17 in and plug 17 in, and then use your calculator. And you get negative 380. And then it says, explain the meaning of this. So h at 17, when you are the people entering compared to the people leaving, then at 17, which is what time is that? 5 at 5 p.m. How many people are actually there? So when it says that 3,725, there are 3,725 people at the park, because it takes the people going in and the people leaving. So entering, subtract leaving, how many people are left in the park at that time, which is at. The derivative on the other end tells you the rate. So at 5 p.m., the rate is decreasing at a rate of 380 people per hour. So because it's negative, the number of people in the park is going down. The rate is going down at that rate per hour. In terms of, on average, 380 people are leaving the park more than entering. So the difference between it, there's if you take the whole amount, if you go hour by hour, it's going down by 380. All right, part D, there's still one more part to it. At what time does the model predict the number of people in the park is maximum? So for that, we have to take that model. This gives me all the people entering and leaving, and make it equal to 0. So we just said that that is e at t subtract l at t. So to find a maximum, you may take the derivative equal to 0. The derivative was this, we just did it. So we're going to take our calculator and solve it. When are they equal to each other, ultimately? And then solve it. Here. So what do I mean there? Go menu algebra, solve. I know there's a bit of a shine here. The first equation is 15,600 t squared subtract 24t plus 160 equals another fraction, leaving 9890 t squared subtract 38t plus 370, and then comma t, and then answer it. So there you go. And so we don't need 46 because it's the time between 0 and or 9 and 23. So the answer we're looking at is 15.795. So 15 at 12, it's noon. So 15 is 3. So it's like 3:45 p.m. if I was going to put it. And at that time, it's a maximal. All right, number 3, next question. An object moves along the x-axis. We have an initial position of 2. The velocity is given by this equation, sine pi over 3 t, and then some questions. What's the acceleration? So the derivative of the velocity, so that's cosine pi over 3t with a hook of pi over 3, and then plug in 4. For a calculus exam, we don't even have to simplify this. So pi over 3 times 4 times pi over 3, just leave it. And then do we have units? Nope. And there it is. Part B, considering the two statements. So one is from 3 to 4.5, the velocity is decreasing. From 3 to 4.5, the speed of the object is increasing. Are either or both these statements correct? For each statement, provide a reason why or not. So I'm going to take that velocity and I'm going to graph it to have a better. Whenever I'm dealing with trigonometry, I want to graph it if I can. So I'm going to clear what I have. Start again from scratch. Press tab. So I'm going to type in sine, and I'm going to use x. So that's pi over 3 x, and I'm going to graph it, and I'm looking from what number to what number? From 3 to 4.5. So I'm going to change the menu. I'm going to go to the window, and I'm going to change it, press 1, and I'm going to go from 3 to 4.5. And I want to see what the graph looks like. So I can see on this graph that from 3 to 4.5, the velocity is negative, and it's going down. So when the velocity is negative and the acceleration is going down, let's explain what that means. So first of all, the velocity is negative from, what are the two numbers? From 3 to 4.5. The acceleration is also negative because it's decreasing. So when the velocity is decreasing, so it's not just below the axis, but it's decreasing, it's also negative from 3 to 4.5. When these match, what that means is it is the velocity is increasing, or the speed is increasing, because the signs match. So the velocity and the acceleration share the same sign. So If they're both negative, the speed is increasing. If they were different, so one was positive and one was negative, then the speed was decreasing. All right, part C. What is the total distance traveled from 0 to 4? So to do that, total distance is absolute value of the velocity. So this changes all the areas to be positive, and you just type it in with that velocity equation. Use your calculator, you can do it. And the answer is oh, by the way, both statements are correct, right? The velocity is decreasing and the speed is increasing. So statement 1 and 2 are correct, just so you know. I wasn't like reading the statements again. 1 says the velocity is decreasing. That's true. Is decreasing and the speed is increasing. All right. If the velocity is decreasing, that means the acceleration is negative. Got it. All right, type this in with that velocity equation. And the answer you should get is 2.387. All right, the last one, part D. What is the position of the object at time equals 4? So the initial position they said was 2. That's when we started at 0 and we want to know 4. So we want to know the position of 4. The initial position given is 2. And then at 2, the position 0. And then we want to know up to 4. And we would integrate the velocity and then use our calculator. And you would get 3.432 as an answer. All right. Next, turn the page. We're halfway there. 4. But we're doing it together. You're not doing it alone. The graph of the function shown, I think there's something that didn't come through there, consists of 2 line segments right here. I think it means f at x, shown there. Let g be the function given by that. So here's another classic kind of question where you're given g at x goes from 0 to x, f at t, dt, and then it gives you questions. So what's g at -1? What does that mean? It means you integrate. What's the area from 0 to -1? So from -1 to 0, what's the area? So that's this right here, this triangle right here, half the base times the height. Now, the line segment here, the slope goes down 6 in this way, so it goes down 3. So it is right there at 1 then, because it does go down 6 and to the left 2. So down 3, 1, down 3. Perfect. So it's right here. So half the base times the height. So that's 3, right? Half of 1 and 3. 3 over 2. Haha. So this answer, the area is... Now, because the bounds are flipped, you change the sign. So notice the bottom number is bigger than the top number, so should have been positive 3 over 2. But with the bounds flipped, you just make it the opposite sign. So now it's negative 3 over 2. All right, next one is the derivative. So to know the derivative of that, the derivative integration cross out, x just plugs in, so it's just f at x. So the derivative at -1 is just f at -1. So you just look off the graph, and what's the y coordinate at -1? And that answer is 0. And then the second derivative is the derivative of f. You just keep following that pattern. So that means at -1, what's the slope there? And I think we talked about it. It is 3 over 1, up 3 over 1. So the slope of that line there at -1 is 3, up 3 over 1. Okay, part B. For what values from -2 to 2 is g increasing? So g is increasing when the derivative is positive. So this derivative is just equal to f at x. So where is f at x above the axes? That's from -1 to 1, it is increasing. So from -1 to 1, the graph is above. Part C, what values of x is the graph concave down? So that's the second derivative in terms of where it's negative. So the second derivative is equivalent to the first derivative for f. And so if that's true, where on the graph is it decreasing, going down? So that's from 0 to 2. So from 0 to 2, you have a negative slope going down. That means concave down for g. D, on the axes provided, sketch the graph of g on the closed interval from -2 to 2. So we'll just create our own. So let's do first of all the derivative for g. So the derivative of g is f at x. We have critical numbers at -1 and 1. It goes below, above, and below. So that means we have a minimum and a maximum. For the second derivative, we have a turning point, or it's undefined at 0. And so it increases and then decreases. So that's concave up and concave down. So we don't have a starting point, right? So just from -2 to +2. So on -2, wherever you want to start, it's going to go down, and then there'll be a turning point, and it's going to be concave up all the way to 0. So here we go like this. So there's that part right there. So it goes down, and then from -1 it goes up, and it's concave up. Continues to be concave up. At 1 is another turning point. And just make sure that it all matches. So this says, does it go down? The next part, does it go up? And the next part, does it go down? So it matches. Is this concave up to 0, and then is it concave down to 2? Perfect. So this matches that. That's what that graph would look like. Number 5. A container has the shape of a cone. You see a picture of it there. And the height of it is 10, and the diameter is 10. The water in the container is evaporating, so it's going down, so that the depth h is changing at a constant rate of -3/10. And it says, it gives you the formula for the volume of the cone. So we'll start there. 1/3 pi r squared h. And it says, find the volume of the water in the container when h is equal to 5. So when I look at here, I need an expression for the radius and the height. So when I look at that picture, I can see that the radius is always half the height. So the radius is 5, and the height is 10, and no matter, there'll be similar cones going all the way down. And so the relationship between the radius and the height is that the radius is always half the height. So I'm going to plug that in for the radius. It's half the height. It might be helpful to simplify that, so I'm going to. When I square it, 2 squared is 4 times 3. That's going to be pi over 12. And then h squared and h, that's h cubed. So it might be helpful to have it simplified for our next step. It may not. To know how much volume of water contained when h equals 5, I need to integrate in terms of what it is. Well, no, I can just plug in 5 here. So what's the volume at 5? I would just plug it in. Done. And we need units. What is it? Oh, centimeters cubed. Done. Okay. Yay, that wasn't so bad. B. It says, find the rate of change of the volume. That's the derivative. with respect to time when height is 5. So I want to take the derivative of this. So I've already done the hard work of that. So the derivative of the volume with respect to time. The derivative here is 3 times that. The 3 goes into 12 4 times. Subtract 1 to the exponents, and then we need the hook dH by dt. And then we're going to plug it in, what we know. So we know the height is 5, right? And then we know that the height is constantly changing at a rate of negative 3 over 10. So when I see that negative 3 over 10, it refers to the rate of the height changing and going down. And then you would type that in, and you would get whatever you would get. 25. Anyway, you don't even need to simplify it down. And the volume, again, would be centimeters cubed per, what's the time? Hour. And you'd have your answer. Part C. Show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality for part C? Doesn't that sound fun? So the area of the base is pi r squared. So when I took the derivative of the volume, so volume is pi 12 h cubed. We did that already. When you take the derivative, this is what we got. Now we're going to flip it around in terms of the radius. So the height is twice whatever the radius is, and we're going to plug that in. So we got pi over 12. The height is twice the radius, and then dH by dt is negative 3 over 10. And then I'm going to simplify this. So I have 3 pi over 12. This is 4r squared. And this is negative 3 over 10. So 3 times 4 is 12 divided by 12. So I just left with pi r squared times negative 3 over 10. So our answer, see, this is the area of that surface area of that, which is a circle. So when it asks for what's the constant of proportionality, the answer is negative 3 over 10. So it's always negative 3 over 10 times whatever the surface area is, pi r squared. Tricky, but we got through it. Last one, number 6. In number 6, let f be a function, differentiable. There's a table involved that you can see above from negative 1.5 to 1.5. And you got the first derivative and the function. The second derivative has the property that the second derivative is always positive between negative 0.5 and 1.5. All right, so evaluate from 0 to 1.5 that, and then show the work that leads to your answer. So if I want to evaluate 0 to 1.5, 3 times the derivative of that plus 4. So first I have to do the antiderivative of what I see. So the antiderivative of f prime at x is just f at x, and the antiderivative of 4 is 4x, and then it's from 0 to 1.5. So there is the antiderivative. And then I plug in 1.5 for f at x, which is negative 1. Just look off the chart. And then 1.5 for x. And then you have your answer. You don't have to simplify it. B, write an equation of a line tangent to the graph of the point where x equals 1. So if x equals 1, that means y, looking off the chart, y is negative 4. And the slope there is 5. So it should be y equals 5, x minus 1, minus 4 for the tangent line. And then it says use a number to apply it, then just plug in 2.1. So 5, 2.1 minus 1, take away 4. Is it 2.1 or 1.2? 1.2. Sorry. You don't have to simplify it. There it is. Not too bad. And then, is this approximately greater or less than the actual value? So, to understand that, I want you to look at the derivative charts and realize the we have to look to see if it's concave up or concave down or increasing or not. So this is less than because the graph is concave up in the interval. So if it's concave up, because it says the second derivative is always positive, the tangent line is lower when it's concave up. Either way. So whether it was increasing or if it's decreasing, concave up, the tangent line is always below. So it's the estimate is less. That's because the second derivative is greater than 0, and the tangent line then is connected would be less than that. All right, almost there. C. Find a positive real number r having the property there must exist a value c between 0 and 0.5 where the second derivative is equal to r, and then give a reason for your answer. So in order to understand that, this is this y2 minus y1, x2 minus x1. But I'm going to do that with the first derivative. So this is the average rate of change for the first derivative. So at 0, it's 0. Sorry, at 1/2, it's 3. And at 0, it's 0. And then it's just 1/2, take away 0. So 3 divided by half times the reciprocal is 6. So that's the mean value theorem. So that's what r must equal. So they're saying what r value must it and give a reason for your answer. So there must be a time there where the acceleration must equal 6 to equal the average rate of change of the velocity. Part D, last one. You're given that function. It's a piecewise, and the graph of g passes each of the points of x and f at x, given in the table above. Is it possible that f and g are the same function? And then give a reason for your answer. So the derivative of g is going to be 4x minus 1 and 4x plus 1. The derivative at 0, so when I plug 0 on top and 0 on the bottom, I have two different answers. So it doesn't exist. And when I look at f at x, the derivative does exist. So for f at 0, the derivative does exist. So therefore, it cannot be the same function. Because for one, the derivative exists. The other one, it doesn't. All right, Mr. G Math, over and out. I am so proud of you for doing your work. Till next time.